Welcome to solverfy.
Okay, this is question 28.44, and we have the same situation in the question right before. So we have a coaxial cable, we have a wire with current I1 inside, and then another thick cylinder on the outside with current I2. And now what we want to do is consider the case where these two currents are going to be in the same direction, and we're assuming that they're different. So there's I1 inside and I2 outside. And in the first part of the question, we want to consider a point where the radius or the point is in between these two, between radius A and radius B. So some point maybe here, and we're going to call that's our R that we're considering. So we want to look at this point R here. This is going to be some distance, again, R from the center of this first wire. So to calculate this, we're going to want to use the fact that the integral of the magnetic field is going to be equal to mu naught times the current enclosed. So this I here represents the current enclosed by this line integral. That's what this is. There's really should be a little circle here to indicate that this is a line integral, indicating a circle. If we were to draw a circular line around here, the current enclosed is going to be I1 here, and this is at this point R. So we can use this to solve for B. So we have, we don't know B, that's what we're trying to find, but the DL, the circumference of this line integral, this circle that we're drawing, is going to be 2 times pi times R, because R is now the radius of this circle. And that's going to be equal to our mu naught. And now the I enclosed, the current enclosed, is just going to be I1. So we know everything here except for B, which is what we want to try to solve anyway. So we can just solve this simply for B. And we're going to get, by dividing both sides by 2 pi R, we get this expression for the magnetic field. B is going to be mu naught times I1 times 2 pi R, divided by 2 pi R. And notice that I2, because it's not enclosed by this line integral that we've drawn, doesn't come into play at all here. So I'm just going to note that this is the solution for part A. Now looking at part B, we can do the exact same thing, except now we're considering some R all the way out here. So this is going to be our new R. This point is now outside of both of these two wires. So what we want to do, we can use the exact same equation here, the same setup, except now the current enclosed, notice, is going to be I1 plus I2. They're in the same direction. It doesn't really matter which direction. We can pick either one. The question doesn't specify. But since they're in the same direction, we can just simply add them. And that means that when we solve this for B, we're going to get B is equal to mu naught times I1 plus I2 divided by 2 pi R, where now R is going to be outside of the cylinder.